Whistling. What exactly are we doing when we are whistling? We are making a high pitched sound by blowing air into a narrow opening. Now, all whistles don't sound the same. Hence, we can categorize the nature of a whistling sound into three categories. A very high pitched sound that is made by blowing very quickly with force. A melodious sound that can be made with controlled blowing. And random frequencies where the sound fluctuates without any control. This is the semantic structure of a whistle in context of a sound. Imagine a whistle that does not look or feel like a whistle, but in technicality, is one. That's exactly the experience we want our users to have. After making a few survival whistles out of used cans, we realized that the factors determining the frequency of the sound are as following: the way of blowing, the size of the inlet, and the size of the outlet. Let's finally make whistles with stoneware clay. After making tubes with variation in size to see which factors affect the pitch of the sound the most, we realized that the most important variable is the relation of the angle of the outlet to the blocking wall that lets air pass through it. Ideal specifications of a whistle are that the wall stands exactly perpendicular to the tube and the angle of the outlet stays 45 degrees. Taking inspiration from other musical wind instruments, such as the flute, we get a whistle that sounds like this. When the fluctuations of the pitch can be adjusted, the whistle is pushed out of the typical category and the tubular forms makes it seem like a musical instrument. By now, we know that the sound and form of a whistle are interdependent. Now that we have derived sound by changing its form, let's focus on the sound to derive a new form. These whistles are made with varying cavities. By making whistles with different cavities to see how sound resonates in chambers of different sizes, we see that when we let air enter the cavity directly, we give air more space to resonate and hence drive the sound away from typicality. If we increase the number of outlets now, just like a flute or an ocarina, we get something that sounds like this. If we continue to add water to these forms, we might get bird sounds. But will all of them sound the same? If we mimic the sound oscillations of different birds accurately in the whistles, we might be able to derive sounds of different birds. And not just birds, but also creatures that have a high-pitched sound, like a tiger pistol shrimp or a whale. But that's a story for another time.